welcome. In this tutorial, we'll have a look at 3D object models in MVTec HALCON. A 3D object model is a data structure that describes the surface of a 3D object. In this video, you'll learn what information is contained in 3D object models, how to visualize them, and how to create and process them. Let's start with a simple 3D object model. This local procedure produces a 3D object model. We'll have a look at the details later on. In the variable window, we double-click the 3D object model. This opens the Inspect window. Click here to display the model. To help us interpret the pose of the object, we can display the coordinate system. The red arrow represents the x direction, green is y, and blue is z. For more information about poses and 3D transformations in HALCON, please have a look at the linked tutorial. Here, the center of the object is roughly at the origin, and the diameter is about 5.6. But what's the unit here? The HALCON calibration plates use meters as the unit of measurements, but your CAD models, robots, 3D sensors, or other hardware may use different units. It's important to convert all data to the same unit and use the 3D object models accordingly. This 3D object model consists of a number of points. We can visualize them by choosing the corresponding attribute in this drop-down list. To represent the surface of the object, we use triangles. To visualize the triangles, we set the displayed attribute to faces to visualize the surface, and then click here to display the polygons. Lastly, we want to be able to differentiate between the inside and the outside of the object. Therefore, this model includes point normals, which define the surface orientation of the points. We can display the normals as well. To be able to see them better, we increase the transparency of the model display by lowering alpha, and change the color of the normals. Here, all normals point inwards. In HALCON, we call the points, triangles, and normals the standard attributes of the 3D object model. You can use this button to insert code representing the current visualization into your program. However, this visualization with DISP object model 3D is static. To get an interactive visualization, you can use the procedure Visualize Object Model 3D. Thus, we can visualize the 3D object model. Its points, triangles, and normals. Next, let's have a look at how we created the 3D object model to get to know more functionalities. First, we create a 3D model of a sphere, which is defined by its center and radius. This is a 3D primitive. HALCON also includes boxes, cylinders, and planes. Primitives are mathematical representations. In general, they do not contain points. To be able to process the sphere better, we add points to the primitive by sampling it. Next, we want to add a bit of noise to this sphere. Therefore, we query the x, y, and z coordinates of the points. Next, we compute the noise. Using the original coordinates in the noise, we generate a new 3D object model, a kind of noisy sphere. Then, we triangulate this 3D object model and thus get a surface. Lastly, we rescale the object using an affine transformation. Here, we created the 3D object model from scratch. You can also read and write 3D object models in different file formats. Thus, you can also read CAD data created in other software products. Alternatively, 3D object models may also be the result of 3D sensors or other 3D reconstruction methods. Now, let's switch back to the main program to see even more ways to work with 3D object models. Smoothing, for example, allows you to reduce the noise of your model. Additionally, you can simplify your model to reduce the number of points while preserving the original geometry as much as possible. This can help reduce the runtime of subsequent operations. Next, we create a 3D object model that represents a plane and visualize it together with our object. A common task is the intersection of 3D object models with planes. This is the result here. Let's go back to our original 3D object model. With Distance Object Model 3D, we compute the distance of the points of the object to the plane. After executing the operator, you can see the extended attribute distance here in the model handle. Extended attributes can contain arbitrary information. They can be attached to the standard attributes or to the 3D object model as a whole. Extended attributes can be the result of operators, like here, or they can be user-defined. The names of user-defined extended attributes start with an ampersand. Now we can use this attribute, for example, to visualize the distance. We can also query it and use it to select certain points from the 3D object model. Here we select all points with a distance between 0.5 and the maximum distance. The result looks like this. Using Select Points Object Model 3D with the attributes neighbor distance or numNeighbors can also be useful to reduce noise of 3D objects. Lastly, we can use this operator to compute the connected components of the 3D object model. As a result, we get two separate 3D object models. Thus, you can separate your 3D object models and process them individually. This concludes this introduction to 3D object models. You can download this HDevelop program to try it out for yourself. Of course, there are many more operators and HDevelop examples to discover. Thank you for watching.